All right. Let's get started. Number one. Number one is dealing with what we talked about yesterday. We didn't quite, I don't think we went too in depth into it. We will go really deep into rotating things about the X and Y axis and different axes. Okay. In fact, well, let me graph this one. So you have y equals x squared, which is a parabola, right? And we're taking that parabola from 0 to 3, and we're revolving this curve around the x-axis, right? So can you visualize kind of the shape that it makes? A raindrop? It's kind of like a cone, but it's caving in. Kind of like the lance, a lance on a knight's, Yes. It's lance, yeah. Okay, well anyway, so it's going to revolve, it's going to duplicate on this side in a sense, and then we're going to get a circular shape there, right? Okay. Now, we are approximating, because we don't know how to find the volume of that yet. We will learn, okay? But we're approximating by doing 3 subintervals. So how wide is each subinterval? 1, because what do? We take the total subinterval and divide it by 3 subintervals, or the total interval divided by subintervals. So each one is 1 and 2, I guess, right? And so we kind of get 2 more circles, in a sense. So you have kind of the cone here, and then part of the cone, and then part of the cone. You guys see that? Now, again, we're approximating using, instead of rectangles now, what shapes are we using? Because as we rotate that rectangle around, we get a cylinder, right? So maybe the better version of this would be something like this. And then like this. So it's almost like a cake. Can you see that? Yeah? Okay. Now, how tall is each cylinder? Again, we're looking at it sideways. These are each 1. And the radius of each cylinder is the distance from the center. What represents the center of this shape? The x-axis, right? So what represents the radius? The y values, right? Now, are we doing a left, a right, or a middle? Right. Okay, so that means in this part, in this piece only, which piece are we using? We're using this height, right? So how do I get this height?
You plug it into the function.
I plug it into the function. So how tall is it?
1.
It's 1, right? And then out of this one, so here's the cone here, we're using the right-hand side. So this, I guess. So it's going to be, 4, because we're plugging in 2. And then this one is going to be 9. Okay? So now the volume, actually the volume of the whole thing is approximately, how do I find the volume of a cylinder? So pi, what's the radius of the first cylinder? So 1 squared times 1 plus pi times what's the radius of the second one? So it'd be 4 squared times 1 plus pi times wait a minute, hold on. Yeah, 9 squared. Christina, did I tell you something wrong? I'm sorry. I forgot that we were squaring the radius when we were done with it. The radius is the x squared, and then we have to square it. I'm sorry. So volume equals, that would be pi plus 16 pi plus 81 pi. So that's going to be 98 pi. Are you okay with that? So the volume of the cylinder is pi r squared h, right? the radius is determined by the equation y equals x squared. So we found the radius, this distance, by plugging in 1 to our equation, which is 1 squared, or let's use this one. 2 squared is 4, so the radius is 4, and then we have to plug in the 4 to square it. So you're kind of squaring twice. Yeah, okay. Are we good with this? No as in I need more time, and no as I don't understand. Huh? Erica, I don't understand you. All right. Number 2, we are looking for the derivative when x equals 1. So you could solve for y. That wasn't my intention, but it's fine if you do. What rule would we be using to find the derivative of this if we don't solve for y? What's it called? Chain, but there's a word for it. Implicit differentiation. Chain's a word too, yes. Implicit differentiation. Remember taking the derivative of y in respect to x. So what's the derivative of x? Or x cubed? 3x squared. Because x is a what in this case? X is the variable and y is the function. Okay, so what rule do I have to find the derivative of 2xy? Product. So what's the derivative of the first thing? 2 times the second thing plus y prime times 2x. And that equals 0. Now I'm looking for y prime. I'm looking for dy dx. So I need to know what x and y are to find y prime, right? So you could move it all over, and that's fine. I don't want to, but let's plug in what we know. We know x is 1, so we're going to say 3 times 1 squared plus 2 times what's y? We don't know. We've got to find y by plugging it into the original equation. So if x cubed plus 2xy equals 9, we're going to say 1 cubed plus 2 times 1 times y equals 9. And then we get 1 plus 2y equals 9. So 2y equals 8. So y equals 4. So we can plug that in here. 2 times 1 equals 0. What was the question? No.
But the last time we did a warm-up problem like that, you said we could be in terms of y.
But you didn't specify.
If I'm just asking for dy dx in general, the function or the equation, then that's fine. No, it says what's dy dx when x equals 1.
But I'm not wrong. Like, that is dy dx.
But by you writing it that way, you're implying that y could be anything. And it can't be because x guarantees a certain y. Sorry, you lose a point. So y prime equals negative 11 halves? All right, there it is.